Hi, in this lecture I want to see how we can view matrix vector multiplication instead of just matrix vector multiplication, but as a linear transformation, or kind of how we can use matrix vector multiplication as a function that takes in some vector and then kind of transfers it to some other point in Cartesian space. Alright, so let's take an example vector to start off with. And this doesn't really have a text component in the deep learning textbook. I'm just kind of saying this stuff quickly so the next few lectures make a little more sense when we talk about matrices in this different light than we have talked about them before. So let's say we have some vector 1, 2, and let's call this x. Okay, so let's plot this on a Cartesian plane. Let's make our 1, 2, 3, 4, 1, 2, 3, 4. Okay, that's our Cartesian plane there. So let's plot out this 1, 2 vector on there. So 1, 2 is going to be here. All right. So now let's create some transformation matrix T. So that's just going to be any old 2 by 2 matrix. So let's say that's going to be 1, 1, 2, 1. And let's call this T. So if we multiply this x by t, we get some vector 1, 1, 1, 2. So that's going to be 1 times 1 is 1, 1 times 2 is 2. So that's going to be 3. And then 2 times this, 2 times 1 is 2, 1 times 2 is 2, 2 plus 2 is 4. So that's going to be a resultant vector, and let's call this x prime. Okay, so let's draw x prime on this. 3, 4. So let's call this x is x prime. Alright, sorry, x prime, not x1, x prime. Okay, so you can see how this transformation matrix T kind of encodes the transformation from x to x prime. And you can kind of see this matrix not just as a matrix vector multiplication that gives you this resulting vector, but you can kind of think of this matrix T as being a function that takes in vectors x and then spits out some vectors x prime, which kind of relocates them somewhere in the Cartesian space. So this idea of kind of thinking of matrix vector multiplication instead of just as a linear transformation that takes in some vector and puts them somewhere else in the place, and you can almost imagine as every single point in space, so every single vector in space, going through this linear transformation and being shifted to some other place throughout the board. You can almost think of as the grid lines in the Cartesian space actually moving because of a result of the transformation. That's kind of why we call it a transformation, is to kind of elicit this mental image that you're not just kind of spitting in some single vector and then getting some vector that replaces here, but you're kind of thinking of every single point undergoing this transformation when multiplying by this matrix and moving to some other point in the Cartesian space. So that's all I wanted to mention here, is just kind of how we can think of matrices in this way, as instead of almost a function that takes in vectors and outputs them some other space else. Alright, see you in the next video.